In this class, now I am going to discuss with you nature of roots of a cubic polynomial equation. Consider a cubic polynomial equation x cube plus ax square plus bx plus c equal to 0. This is the cubic polynomial equation. And you know, students, as per the fundamental theorem of an algebra, nth degree polynomial equation will get n roots. You know this. That roots may be real or complex. Whenever an equation gets complex roots which comes as pairwise, means that complex roots may be 2 or 4 or 6, 8 and so on. Even number of complex roots will occur. And also that complex roots are conjugate to each other. You know the meaning of conjugate complex roots. If one of the root is 2 plus I, then other will be 2 minus I. Now let us come to this cubic polynomial equation. Cubic polynomial equation will get either 3 roots as real or 1 root as real, but it will not get 2 roots as real. Okay students, remember that point. If 3 roots are real, no problem. Number of complex roots 0. If 1 root is real, then leftover 2 roots will be complex. But if it is has 2 real roots, then is other root will be complex. That is not possible now. As I said to you, whenever the equation gets complex roots which comes as even number of times, hence 2 real roots is not possible. Either it may have 1 real root or 3 real roots. Remember this point. Now let us discuss whose roots nature. So now I would like to consider this left side portion of an equation as f of x. F of x equal to x cube plus ax square plus bx plus c. Now I would like to find whose first derivative. F of x equal to 3x square plus 2ax plus b. This is the first derivative of cubic polynomial. After doing the first derivative, I got a quadratic equation. Find whose discriminant value. It is denoted by the letter d or delta. Now you know formula for discriminant value of a quadratic equation, b square minus 4ac. In the place of b, there is 2a, 4a square minus 4ac, 4 3s are 12, 12b you will get. This is the discriminant value of this quadratic equation. You know students, you have studied in the schooling and also in the last chapter quadratic equations. There you have studied about nature of roots of a quadratic equation. Whenever the delta is positive, roots are real and distinct. Whenever the delta is equal to 0, roots are real and equal. When delta is less than 0, roots are conjugate complex roots. See, here I prepared delta. If I get delta is negative, then what do you comment on the roots of this equation? Those roots may be complex roots which are conjugate to each other, because I took delta is less than 0. What is delta? Discriminant value of first derivative of cubic polynomial. I got 2 roots alpha and beta which are complex roots. Actually, what is meant by first derivative? Slope of the tangent which is drawn to the graph of the given function. It is a polynomial function, and this first derivative represents slope of the tangent drawn to this curve. And what are alpha and beta in this case? In this case, imaginary roots. Okay, students. So in this case, if you would like to draw the graph of this cubic polynomial, you get like this. See, your graph will be like this, strictly increasing. Either you may get like this or like this. Okay, students, because on this curve, if you take any point, there if you draw the tangent can never be horizontal, never be parallel to the x-axis, because slope of x-axis is 0, and if you draw any tangent, if it is horizontal, means parallel to the x-axis, slope is 0. But here at this alpha and beta first derivative, here both alpha and beta are not real numbers, so on the x-axis we can't able to take alpha and beta. On the x-axis you cannot able to take alpha and beta because both are complex values, complex roots. But here it is a real x-axis. Hence this should not be taken on x-axis. So this first derivative is always positive for this. F dash of x is positive, strictly increasing function. If you take x belongs to anywhere on this x-axis, you get strictly increasing function. So here either this graph of this function may be this or may be this when delta is less than 0. If it is this, now here it is intersecting on y-axis at 0. If I put here 0 in the place of x, I get c. Now c means this distance. Here c is positive. C means this distance, it should be positive. So here, if I see, here it is intersecting on negative x-axis here. If I write here 0, again you will get c. But in this case, this c is negative. So in this case, this curve is intersecting x-axis at negative portion on x-axis. Means this is a negative real root. In this case, this curve is intersecting on x-axis in the positive portion of x-axis. Hence, this root is positive real. This is positive real. This is negative real. Means what you people are coming to know by this cubic equation will get only one real root. Then other two will be complex, conjugate to each other. Okay. Here what did I do? Just I did the first derivative. I prepared whose discriminant value, and if I observe this discriminant value is negative, then you people have to say that this equation gets one real root and two complex roots which are conjugate to each other. This one of the root may be negative, may be positive. If it is negative, then this constant which is placed in the given equation is positive. If it is positive real root, and this c must be negative. Observe that. Right. Next, if I take delta is positive, suppose delta is positive. If delta is positive, means this first derivative will get two roots which are real. In this case, alpha and beta are real, because here I took delta is greater than 0. First derivative discriminant value is positive, means on equating this one equal to 0, you get two roots, the two roots as real. In this case, if you go for the graphs, you get like this. See here, this is x-axis. Your graph may be like this. Otherwise, your graph may be like this. Otherwise, your graph may be like this. Otherwise your graph may be like this. See here. Otherwise you may get like this. You may get like this. So this 5 possibilities will come when delta is greater than 0. Now let us discuss one by one. Delta is greater than 0 means here roots of this first derivative of cubic polynomial are real, alpha, beta, where alpha is going to be 0, beta is going to be 0. Because these two obtained by equating this one equal to 0, which means that at alpha and beta this first derivative equal to 0. So if you see this diagram, see this is x-axis. So here if you draw tangent and at this point and at this point both are horizontal. At these points first derivative of this function becomes 0. Hence whose lines are parallel to x-axis means whose slopes are equal to 0. So that here you have to take this is alpha and this is beta. No confusion. Okay. So here x coordinate of this point, x coordinate of this point are alpha, beta. So both points are there in third quadrant. Means here below the x-axis. Hence f of alpha, f of beta for these 2 points. This is point of maximum, this is point of minimum. F of alpha is negative, f of beta is negative. So if you take whose product, f of alpha into f of beta, you will get positive. Okay students. Now go to this diagram. Same this case only will come. So in this case only one negative real root. When f of alpha and f of beta is positive, here what it is? Negative real root, because this curve is intersecting on the negative portion on the x-axis. Hence it will get one real root and the remaining other 2 roots will be complex. Now go here. Here also. Here also. Here it is alpha, here it is beta. Now at this point if you draw the tangents which are parallel to x-axis, hence whose first derivative becomes 0 at these points. So here f of alpha negative, f of beta negative. If you take whose product, same this condition only will come. Now come here. So here you have to take alpha, here you have to take beta, because at these points if you draw the tangents, so this is the slope of the tangent. Here this represents slope of these tangents at alpha and beta, because alpha beta are the roots of this equation. So in this case this curve is intersecting x-axis at how many places? 3 places. Hence the number of real roots 3. Here no complex root, but in this case 2 complex roots, 1 negative real. In this case 1 positive real and the remaining 2 are complex roots. Now in this case here it is first derivative becomes 0, and because touching the x-axis not intersecting, here second derivative. So here you can take this is here you can take this is alpha, this is beta. Now f of alpha 0 na, hence f of alpha into f of beta, which becomes 0. So here 2 roots, one is alpha and other is, here you will get not beta. These roots are alpha and other root which is more than beta. Take any value. Okay, these are rough diagrams, no students. So these roots are 2 roots are equal. The 2 roots are negative and one is positive real root. And go here. However this, but 2 roots are equal and one is other than these 2. And here also 2 roots are equal. Here it is touching at this point na, let it be beta comma 0. And here alpha. Okay students. You can bring it to the down. So here it is intersecting x-axis at 1 and touching at 1 place. At touching place roots are equal. Beta you have to take. Here it is any other value which is smaller than alpha. So here you are getting 3 roots, here you are getting 3 roots. But in both cases, f of alpha and f of beta 0. Because here f of beta 0, here f of alpha 0. Then whose product would be 0? Here 3 roots as real. Here 3 roots as real. Here 1 is negative real root, 2 are complex. Here 1 is positive real root, 2 are complex. Here 3 roots as real. So this is very, very important. I think you have got it. When delta is greater than 0. 5 possibilities are there. See the conditions. And sometimes you may get this delta is equal to 0. Delta is equal to 0. If the first discriminant value of first derivative of this function is equal to 0. If delta is equal to 0, then f of x can be written like this summa. Whenever the discriminant value of first derivative of this function is equal to 0, then this f of x one can be written like this: x minus p into whole power, it is cubic polynomial, no? Write cube, put here some k. You can able to express as perfect cube. Okay. So now what you can comment on the roots of this. If k is 0, then it will get 3 real roots. The 3 real roots are equal. When k is 0, it will get 3 real roots. That 3 real roots are equal. If it is 0, then you can able to write product of 3 linear factors, equate them to 0, so that you will get p. If it is not equal to 0, then it will get at least 1 real root. As I said to you, cubic polynomial equation will get either 1 real root or 3 real roots. Either it may have 1 real root or 3 real roots when k is not equal to 0. So this is the nature of roots of cubic polynomial equation. So here I am having some previous mains and advanced questions which were given based on this concept. Now let me discuss with you those applications. See here. See this question, students. Find the number of real roots of this cubic equation: x cube plus 2x square plus 2x plus 1 equal to 0. What you would have to find? Number of real roots of this cubic polynomial equation. You know how to solve this cubic polynomial equation and solve it, and you can confirm. Otherwise, by this method also you can answer to that question. Actually, generally, so we follow the Arnold synthetic division method to solve this equation. So left side one you have to take as f of x, and in which you have to put x equal to minus 1. If I write x equal to minus 1, it is going to be minus 1, it is going to be 2. Here it is going to be minus 2, here it is plus. Both of them cancel. Result 0. Then you got minus 1 is one of the root. Means, so x plus 1 is one of the factor of this cubic polynomial. X plus 1, here x cube plus 2x square plus 2x plus 1. Now divide this with this, so that here you get the remainder 0 and you get some quotient. Equate that quotient equal to 0, so that you will get other roots. You can answer like this. Otherwise, students, follow the previous procedure. Take this one as f of x and do the first derivative. You get 3x square plus 4x plus 2. This is the first derivative. Okay, now find whose discriminant value. So here b square 16 minus 4ac, 4 3 is 12, 12 2 is 24. You are getting first derivative negative, which means that So how do you get whose graph? As I said to you, when delta is less than 0, you get the graph like this. Either like this or like this. But in this case, if I keep x equal to 0, you are getting constant as positive. Means here 0 comma 1. So you get one real root, that is negative real root. This is not possible. In this case, constant value is negative, but here constant value is positive, means you will get negative real root. One real root you will get, and the rest of them complex roots. But in this problem, what did they ask? Find the number of real roots of that equation. Only it will get one real root. What is that? They did not ask. Okay, find the number of real roots of this equation means one real root. What is that? -1. Actually, in the previous one, by trial and error method, I checked na. You can do like that for this question. But the question was, find the number of real roots of this equation. One is real, two are complex. And see one more question. See, this equation has all real roots. Then find the interval for k. 2x cube minus 9x square plus 12x minus k, which is equal to 0. This equation has all real roots. This equation has all real roots. Then find the interval for k. Now tell me, how do you answer to that question? See, first to take this and differentiate it, f dash of x. On differentiating this, 6x square minus 18x plus 12. From all this you can take 6 common, x square minus 3x plus 2 and factorize it. Now x minus 2 and x minus 1 you will get. On equating these two equal to 0, you get the critical values as 1 comma 2. Now at 1, first derivative is going to become 0. At 2, first derivative is going to become 0. Now draw the diagram for this. At x equal to 1, you may get here. At x equal to 2, you may get here. So your graph would be like this. Because they mentioned it has all real roots, cubic equation. Having 3 real roots, they said. Hence, your rough diagram will come like this. So, intersecting at 3 places, it goes like this. Here, here, here. Intersecting at 3 places, hence it will get 3 real roots. At 1, so here, horizontal, first derivative 0. At 2, here, horizontal tangent. At first derivative becomes 0. So, it is there in the first quadrant. Means here f of 1 is positive. It is there in the fourth quadrant. F of 2 is negative. Now take whose product. Take whose product and simplify. See, f of 1 into f of 2. Here it is positive, here it is negative. When you take product, f of 1 into f of 2 must be less than 0. Now f of 1 means in the place of x you have to write 1. If I write 1 here, it is going to be 2 minus 9 plus 12 minus k. And if I write 2 here, it is going to be 2 cube 8. 8 2 is 16. If I write 2 here, 2 square 4. 9 4 is 36. Here 2. 12 2 is 24 minus k. Here it is less than 0. Now simplify this. This is 14. 14 minus 9. 2 plus 12. 14. 14 minus 9. So going to be 5. 5 minus k into here. This is 40. 40 minus 36. 4. 4 minus k less than 0. From both of them take minus common. So k minus 4, k minus 5. So you get less than 0 only. Now here draw the number line, represent both of them on the number line. Now draw the wavy curve, plus minus plus. Now here we want smaller than 0 means negative. So your k belongs to open interval of 4, 5. So this is the required interval for k to get all the roots as real. Very good problem. I hope you have understood this. Now let us go to one more application. Now see that question. One cubic equation is given. X cube minus 3x plus k equal to 0. Now asking us to find interval for k such that it should get one root as positive, and one root as negative, and a third problem, one root is negative, remaining two are positive. Okay, find the interval for k such that this equation should get one root, one positive real root. So to answer this question, it has to be considered as f of x, x cube minus 3x plus k. Now differentiate it. F dash of x equal to 3x square minus 3. Now equate them equal to 0, so that you will get x equal to plus or minus 1. Now go to the diagram. How you can expect the diagram? X is negative, so x equal to minus 1 plus 1 you got. Minus 1 means where it is minus 1, here it is minus 1, here it is plus. But it should get only one positive real root. One positive real root means how do you expect the diagram? Tell me students, at minus 1 and plus 1, see you expect the diagram like this. You expect the diagram like this, because at minus 1 horizontal tangent is possible, at plus 1 horizontal tangent is possible. Okay students, here f dash of minus 1 0, here f dash of 1 is 0. So they said that it has a positive real root intersecting x axis in the positive direction of x axis. Here it is positive real root. Then find k means here you have to write f of minus 1 is, it is there in the third quadrant, f of minus 1 less than 0. Here it is also below the x axis. No, both are, these 2 points are below the x axis, means along with the y axis you get whose range. So f of minus 1, what it is, this point coordinates minus 1 comma f of minus 1, it is there in the third quadrant, hence f of minus 1 is negative, and it is also there in fourth quadrant, f of 1 is also negative. Now minus 1 if I write in the given one, so minus 1 plus 3 plus k less than 0. Now k is smaller than minus 3, sorry minus 2. 3 minus 1 2, when it goes to the right side minus 2. So when I write here 1 here, 1 minus 3 plus k less than 0. Okay, less than 3. Now what is the required interval for k in this problem? Common portion of these two. Here k is taking minus below minus 2, k is taking 3 below on the number line. So the common portion of these two is k belongs to minus infinity to smaller than minus 2, open. This is the required interval for k. In both, this is the common portion. It is a subset of this interval. Yes or no students? Hence common portion of these two is this will come smaller than minus 2. So now let us go to second question. Find the interval for k such that it will get one negative real root. 1 and negative real root means how do you draw the diagram? Same. Here -1 plus 1 are critical points. 1 and negative real root. Same interval I think you will get. See x, x dash, y, y dash. So you get the graph like this. Sorry, not like this because -1, 1 no. X, x dash, y, y dash. See, -1 and 1. -1, 1. These are critical points. That graph should get negative real root. Yes. Now it is. Is this possible? Students, tell me. Negative real root. Yeah, in the previous one this was over. Positive real root. Negative real root means that curve should intersect in the negative portion of this. See, negative portion. You can take like this. You can take like this. See, intersected at two places, so not possible. Here itself you have to leave. Here itself you have to leave. Yeah, this is correct diagram. So this is origin. Now here at 1, horizontal tangent is possible. Here it is -1, horizontal tangent is possible. So at f of 1 positive and f of -1 negative. Now f of 1 if I write here 1 minus 3 plus k is positive, then k is greater than 2. If I apply this -1 whole cube, -1 plus 3 plus k less than 0. K is smaller than -2. K is smaller than -2, k is more than 2. So k belongs to smaller than -2. Minus infinity, no, is there a common portion you would have to take in both. Here it is saying that k is smaller than -2. Here it is saying k is more than 2. Is this possible? No. K is an empty set. K belongs to an empty set. Okay, students. Here k, it is saying that. So here k is more than 2. Here k is smaller than 2. So I said to you to take the common interval of these two. Is there any value is possible for k? No such value is possible. Means, so this is does not exist. Means this equation will not get negative real root. So that we are not getting any real values for k. That equation is not getting negative real root. It may have real roots. Either it may have 1 or 3. Those may be positive. But here negative real root is not possible for this, so that we are not getting any real value for k. Now 1 root is negative and 2 are positive. Next question. Find the interval for k such that 1 root is positive and remaining 2 roots are, 1 root is negative, remaining 2 roots are positive. Means you get the diagram like this. X, x dash, y, y dash. Here it is -1, here it is +1. So see, you get the graph like this. Here, this is intersecting in the negative portion. Means negative real root. Here, in the positive direction of x-axis intersected at two places. Means 2 positive real roots and 1 negative real root. Where? Horizontal line. Where? Horizontal line. So here it is f of 1. There in the fourth quadrant. So hence f of 1 is negative. Here it is, students tell me, here it is f of minus 1 positive. Now here it is negative, here it is positive. Put 2 in one place. Okay students. Okay, because you get the graph of a cubic polynomial like this. Not you will get like, see. Are you getting me students? Now write here minus 1. If I write minus 1, here it is going to be minus 1 plus 3 plus k. So is greater than 0. Now k value is 3 minus 1, 2, greater than minus 2. Here f of 1, if I write here 1 minus 3 plus k less than 0. Now k is less than 2. Okay students, k value is smaller than 2, k is more than minus 2, means the common portion of these two is, so minus 2 less than k less than 2. This is the required interval for k, such that this cubic polynomial equation will get one negative real root and two positive real roots. I hope you have understood this nature of roots of cubic polynomial equation, and I taught to you some applications based on this nature of roots of cubic polynomial equation. I am requesting you to subscribe and like and share my channel so that my classes reaches to many people. Thank you students. Thank you one and all.